from the small intestine to the large intestine. And the large intestine is really different in its structure and its function. Okay? It's a lot wider and it's a lot shorter than the small intestine is. But it is so, so, so important because it is the bridge between absorption and elimination. The two nutrients that get absorbed in the large intestine are water and minerals. Now, the way this happens, there's a reason that minerals are actually not absorbed in the small intestine. Because if it weren't for the presence of minerals still in this moderately soupy mixture, okay, that still has fiber and waste materials that we're not going to absorb, and things that were not digestible, okay, and a lot of water and a lot of minerals. This kind of concoction, there's a reason that the minerals have to stay in there. And that is because they alone facilitate the absorption of water. Okay? Because the minerals get absorbed first, allows the water molecules to follow. And the way this actually works, so if you have your large intestine, which comes up like so, okay, from the small intestine, what happens here, and then your rectum goes down, what ends up happening is blood vessels are very, very closely linked to, or they basically surround the large intestine. Just like they surround, okay, or are really integral parts of the villi on the inside of the small intestine. Here, there's no villi in the large intestine. Okay, the large intestine is very smooth in its interior. And the cool thing here is our blood vessels line the outside. Okay, to the point that if we actually made this, okay, if we actually made this a lot bigger here, okay, and we zoom this out, we see that the border here, there's not much actual distance between that really thin membrane that makes the large intestine and the blood vessels that surround it. The blood vessels that surround it behave very much like a network. Okay, if you've ever bought onions or a little bag of garlic or a little baggie of avocados at the grocery store, they come in these plastic mesh bags. Okay, well, these network of blood vessels are very similar in the sense that they branch out all over the place and they surround these organs. Okay, so the distance is very, very minimal. So here we've got the actual, and I'm going to draw it a little bit thicker here, we've got the actual border of the large intestine. And then we've got the actual blood vessel that is very, very close to it. Okay, and so here's our little blood vessel, our little tube. Okay, and what happens, this is the inside of the large intestine, and I'm actually going to draw that in the same color. So this is the large intestine, and this is the blood vessel. And what ends up happening is we're actually going to draw our little minerals. We're going to draw them in green here. Okay, our minerals are here, and that's minerals of calcium, that's minerals of, and I'll actually draw the element here, that's sodium, that's iron, okay, all of these trace elements that we need, all right, in very small amounts. What ends up happening here is because of something called osmosis, which you've learned about before, osmosis, and we're actually going to move slides to talk about osmosis before we come back here. But osmosis is the movement of particles of water particles from one side of a membrane where there's a high concentration of it to the other side of the membrane where there's a low concentration. And this is what happens. This is an example of two sides of one membrane that have different concentrations of water. And we know that osmosis and diffusion do the exact same thing. Diffusion and osmosis involve the movement of a substance from an area of high concentration, so an area where there's lots, to an area where there's little. This is just natural. And we're going to see that our body actually uses this to its advantage all over the place. Because this is a form of passive transport. Passive involves no energy. This just naturally happens. So your body takes advantage of this whenever it can. So what is going to happen to the amounts of water here if this is a semi-permeable membrane? Which means if this is a membrane that actually has holes in it. What is going to happen here? It's going to move, right? Is everybody in agreement that given the option, this water will go from here over to this side, right? Until what happens? Will all the water that's on the left move to the right? No, at some point they even out. And that's where they're just going to be moving back and forth freely. Right? Whatever moves over here, some will go back to compensate. Right? That is osmosis. Okay? Osmosis follows something called a concentration gradient. And a concentration gradient means that you're going from an area where there's a lot to an area where there is little. And this is natural. This is a passive form of transport. So if we know that osmosis is the movement of water, and in here I've got lots of water molecules, okay? I've got water molecules interspersed with all the other stuff. Now, I haven't drawn any of the fiber or the other waste that's still in that chyme that's making its way through here. Okay, and by the time it gets to this part, it's starting to look more and more like the diarrhea equivalent of feces. Okay, in the large intestine, it's starting to look like feces. This part, or the first part of the actual large intestine, okay, the feces look much different than the third part of the large intestine because water and minerals are getting absorbed the whole way through. I'm just illustrating it over here on this side. Okay, but this is happening everywhere. So by the time the food actually gets to where we've actually enlarged this, most of the water, okay, and minerals that we needed have been removed from the feces, okay? What's real, and we'll talk about feces formation and what's actually left later, after we get through absorption. When we actually talk about the movement, the actual movement of these molecules, the first thing to actually move over are these minerals. Okay, and there's a lot of these minerals actually moving over at any one time. They're passing through these membranes and they're going into the blood. Okay, I've only drawn 3, but imagine you go to the movies and you eat a very salty and buttery popcorn. Okay, there's a high salt content in there. You're absorbing, as you digest that, a lot of sodium. Okay, a lot of these NAs are going into your blood. So now, inside your blood, the concentration of minerals, and this is the symbol for concentration, okay, 2 square brackets. The concentration of minerals is very high. Okay, so because that concentration is super high, the body says, whoa, too many minerals in the blood, I've got to dilute this concentration. Okay, I've got to water it down. I've got to add more water to lower the concentration of minerals, to spread it out more. Okay? What ends up happening after that is these water molecules follow. Okay? First minerals, then the water molecules follow. And the water molecules go into the blood to basically adjust the concentration of minerals. So if there's a high concentration of minerals in your blood, you will get thirsty. Okay, a dry mouth and throat is your body's way of actually saying, hey, the system itself needs more water, consume water so we can absorb more water. Okay, because we need it.